Hello and welcome to this video on solving equations that are quadratic in form. That means that we are going to have some equations that we can write as a quadratic but are not technically a quadratic equation. So for example, our first one we have x to the 6th plus 9x cubed plus 8 equals 0. Now this is in the form that we normally see a quadratic, where we have something in the form of ax squared plus bx plus c equals 0, but our powers on our variable x, instead of being 1 and 2, are 3 and 6. Now anytime we have the situation where these powers are double, one is double the other one, and then we have a constant, whether or not we have that constant doesn't matter, but we can write this in the form of a quadratic equation. And what we're going to do is we're going to use a substitution on this. So we are going to let u be the one that is the power closest to 0, in this case x cubed. If u is x cubed, and we double that power, that's going to give us u squared, because we're doubling our power. We're going to double the power from u to u squared, and then x cubed is going to become u, and so we get the equation u squared plus 9u plus 8 equals 0. That is a quadratic. That quadratic will factor quite nicely. It's going to factor to u factors of 8 that add to 9 are u plus 1, u plus 8 equals 0. Set each of those equal to 0. We get u is equal to -1 and u is equal to -8. Now that we've solved that for u, what we're going to do is go back to our x's and substitute back in. Instead of u, we're going to get x cubed equals -1 and x cubed equals -8. And then we can take the cube root of both sides. Remember, when we take a cube root, we don't have to worry about plus or minus. We only have to worry about the plus or minus if we are taking an even root. And so the cube root of x cubed is going to be x, and the cube root of -1 is -1, because -1 times itself gives us -1. And then on our second equation, we have the cube root of -8, simplifies to -2. You can check both of these. When you plug them back in, you will get the that both of those make a true statement. All right, our next example here technically is a quadratic. We have the quantity 5x minus 5 quantity squared plus 6 times the quantity 5x minus 5 plus 9 equals 0. So we could multiply, expand, and combine like terms and get this in the form of a quadratic, but we can use the same technique and use a substitution and do it a little bit quicker. So here we're going to let u, we still have that same setup where we have a power and then double that power. And so we're going to let u be the one that is closest to 0, in this case the power to the first. So if u is equal to 5x minus 5, our equation becomes u squared plus 6u plus 9 equals 0. U squared plus 6u plus 9 is a perfect square trinomial. The factors of 9 that add to 6 are 3 and 3. So u plus 3 quantity squared equals 0. And then technically we could take this square root of both sides. Here we are using a square root, so we need the plus or minus, and we get u plus 3 equals 0. Plus or minus the square root of 0 is equal to 0 either way. And u equals -3, and then plug our substitution back in. So instead of u, we're going to do 5x minus 5 equals -3. Add 5 to both sides. -3 plus 5 is 2. X equals 2 over 5. And again, you can plug that back in, and it should check out and make a true statement. All right, our next one, we have t to the 1/2 minus 10t to the 1/4 plus 25 equals 0. Now this is one that trips students up from time to time. 1/4, if we double that, we do get 1/2, because 1/4 plus 1/4 equals 2/4, which reduces to 1/2. So students, I'll often see students thinking 1/4 is the bigger one, and they'll put that one out front. But just pay attention to fractions. The bigger the denominator, the smaller the fraction. All right, so on this one, we are going to let our u be t to the 1/4, because 1/4 is closer to 0 than 1/2. We were doubling it, so instead of t to the 1/2, we'll have a u squared. T to the 1/4 is our u. And so we get the equation u squared minus 10u plus 25 equals 0. Again, that one factors quite nicely as a perfect square trinomial. Factors of 25 that add to -10 are -5 and -5. So we get u minus 5 quantity squared. And just like we saw in the other one, we can take the square root. We're going to end up with just u minus 5 equals 0. So u is equal to 5. Plugging that back into our substitution, we get t to the 1/4 is equal to 5. And then to get rid of that 1/4 power, we want to raise everything to the 4th power on each side. And 5 to the 4th power is 625. We do want to check this one, because since we raised this to an even power, we could have introduced something that was negative, introduced an extraneous solution. So I'm going to go ahead and check this one. Anytime you raise something to an even power, you do want to just double check that you're not introducing any extraneous solutions. So 625 to the 1/2 minus 10 times 625 to the 1/4 plus 25 equals 0. 625 to the 1/2 is 25. Square root of 625 is 25. And 625 to the 1/4, well, we actually got that number by raising 5 to the 4th. So that's going to be 5. So 25 minus 10 times 5 is 50, plus 25 does equal 0. So that is our solution. And then another one with a fraction, we have 9x to the 2/3 minus 8x to the 1/3 minus 1 equals 0. Again, we have our exponents where we have 1 is double the other one. And so we're going to let u be the power that is, the x to the power that is closest to 0. And I say that it's going to be the smallest one in magnitude. We could have negative exponents, and it's just going to work the exact same way. You're always going to want your u to substitute into the x that is the power that is closest to 0, or the smallest number as far as an absolute value is concerned. So when we double that, we get u squared. X to the 1/3 is our u. So when we substitute in, we now have 9u squared minus 8u minus 1 equals 0. And we can factor this. You can use any method of factoring. I've got a number of videos out there that go through those different methods. But I I prefer trial and error, so the different ways that you can get 9u squared, you can do 9u and u, or you can do 3u and 3u. The only ways you can get -1 are -1 and +1. And so the combination that we want to get a -8 is going to be 9u plus 1 and u minus 1. You can check that out. You can use the AC grouping method, number of different methods that will get you those factors. Set each of those factors equal to 0, and we're going to subtract 1 and then divide by 9, so -1 and then divide by 9, we get u equals -1/9, and then for our other one, u minus 1 equals 0 when u is equal to 1. Then we want to, just like we did on the other ones, plug back in. Instead of u, we want x to the 1/3 equals -1/9, or x to the 1/3 equals 1. Raise both sides to get rid of that 1/3 power. We want to raise both sides to the 3rd on both equations, and we get solutions of x to the 1/3 to the 3rd is going to simplify to x to the, or -1/9 to the 3rd is going to be -1 cubed is -1, 9 cubed is 729, and then on our other equation, 1 cubed is 1, and again you can plug both of those solutions into your original, and it should give you a true statement. All right, I'll see you guys next time.